Okay, we are on page 39 today. And we're going to take a look at the practice problems that go along with the notes you had for homework over the weekend. Okay. The stuff that we're talking about today, with the exception of, well, not even with the exception of vertex, because you guys saw that in Algebra 1 as well. Everything that we're seeing today, you guys also saw in Algebra 1. I know you saw it in Algebra 1 because we just covered it in Algebra 1. So this is all stuff that you covered about this time last year in Algebra 1, increasing and decreasing intervals, positive and negative intervals, minimums and maximums, and how we further classify those. And then you didn't get to quadratic functions and the idea of a vertex until last spring, but it is also something that you saw in Algebra 1. So this was more of a review, the new material. I'm going to go through these problems with you so that we can talk about this and answer any questions you may have. So on page 39, for our first problem, we are given the graph of a function and we've got some key points identified here for us. Notice that any point on this graph that's identified is either an x-intercept or a minimum or maximum, okay? So as you guys are looking at having to do problems like this on your own calculator, keep in mind that those are the types of points that we're going to need to know to be able to describe these different intervals. So let's start with increasing intervals. Remember, increasing is when I read my graph from left to right, my y value is increasing. So if I were to trace my graph, my pencil would be going up across my paper. So increasing, I'm going to start with increasing intervals. I like to color coordinate my graphs for these problems. You can if you want, but you don't have to. Increasing. Remember, we read graphs from left to right. So as I start reading this graph, I'm not increasing, I'm decreasing until I get to here. Here, I start increasing. So there's an increasing interval. And then I get to this maximum and I turn around and I'm not increasing anymore. And then I get to this minimum and I turn around again and now I am increasing. So those two sections of my graph are increasing. So I'm going to go ahead and write an interval that describes each of those. This first interval, remember we named these by the x values, goes from negative 0.225 until 2.22. We name these using the x-axis because the x-axis is the one that goes left to right, and we read our graphs from left to right. So that's why we use those x values, because those serve as sort of a landmark on my left to right axis. So there's my first increasing interval. And now I want to write my second increasing interval. So it starts at 4. And then this one goes forever, right? If I were to keep tracing my graph, it would keep going up forever. So I'm going to say that this interval ends at positive infinity. That's a way to say that it doesn't actually end. It's going to increase forever. So there are my increasing intervals. And now I want to do my decreasing intervals. So my decreasing intervals are going to be the other parts of my graph. So that first part of my graph where I'm going down, and then we were increasing, and then we were decreasing again. So there are my two decreasing intervals. For my first decreasing interval, remember that this graph goes forever. So I would have been tracing from forever. So my decreasing interval here started when x was negative infinity. And then it goes until negative 0.225. And I will write over this in a color that we can see. There we go, negative infinity until negative 0.225. And then I have another decreasing interval that starts at 2.22 and goes until 4. Remember, I'm always naming my intervals with the x value where they start and then the x value where they stop. Questions for me so far on increasing and decreasing intervals? Okay, now let's look at positive and negative intervals. I tend to say that we're okay with the increasing and decreasing intervals, but we get a little tripped up on the positive and negative intervals. Positive and negative refers to, am I, for this portion of the graph, am I looking at positive y values or negative y values? So we're looking at, am I above or below the x-axis? If we're above the x-axis, that's positive. If we're below the x-axis, that's negative. So as I look at my graph, this chunk that I start with is above the x-axis, so that's a positive interval. So from when x is negative infinity until x is -1, we have a positive interval because we're above the x-axis. We have now a negative interval for this portion of the graph because we're below the x-axis. So from -1 until +1, we have a negative interval because this section of my graph between -1 and +1 is below the x-axis. That makes it negative. Now I've got another positive interval that goes until here, that goes until I hit the x-axis. The x-axis is not above the x-axis. It's also not below the x-axis. So anytime I hit the x-axis, I have to stop my interval. So this is all above. So from when x is 1 until x is 4. When I hit the x-axis, I don't go negative, right? I turn around and I'm positive again. So then I get another positive interval from 4 to infinity. That can be a tricky thing about positive versus negative intervals. Even if I don't go below the x-axis, I still have to stop the interval at the x-axis because it's not above or below. It's sort of a neutral zone. So I have to stop the interval there. Questions for me so far? Okay, now let's talk about minimums and maximums. What's the difference between local and global when I talk about minimums and maximums? Mm-hmm. Yeah.
I guess for what you can see here, like obvious, like, it's just not on the whole like scale.
Yeah, so the difference is for a global minimum or maximum. If it's a global maximum, it's the highest point on the entire graph. There is no point higher anywhere on the graph. A global minimum would be the lowest point on the entire graph. There's no point anywhere else on the graph that's lower. For local, it's a minimum or a maximum. It's a high point or a low point for the area, but it's not the lowest or highest point on the entire graph. So as I look at my graph here, do we have any minimums? Do we have any minimums? Mm-hmm. Right here at 4, 0. Yep. Local or global? This is a local minimum at 4, 0. It's a minimum. It's a low point on the graph. It's not the lowest point on the graph. Do I have any other minimums on the graph? Any other low points on the graph? Mm-hmm. This guy here, -0.225, -6.78. Yeah. Local or global? Well, when you said it, you said the very bottom point, right? Is there a point lower than this anywhere on the graph? So that makes it a global, yeah. So this is a global minimum right here. So -0.225, -6.78. How about maximums? Do we have any maximums on the graph? Katie? You called this a local maximum. You're absolutely right. Do we have a global maximum for this graph? What? So my graph goes forever, right? It means there's not one specific point that's going to be the highest point on the graph. in our minds, we think, well, the highest point would just be infinity. That's the biggest y value, right? Is infinity an actual number that you can count to? Or is that an actual point on the graph that you can point at and say, this is the highest point right here? No. So this is where in Algebra 2, we sort of bring out the big guns when we talk about infinity. Infinity is not a number, okay? So what I don't want you to do is to write infinity for a max or negative infinity for a min, okay? This is where we're gonna sort of kind of expand on our perceptions of infinity. So here, I want you to write none because there is no actual highest point that you can pick out on the graph. So infinity as a concept that we're going to go forever works for our intervals. The problem is that since it's not an actual point on the graph, it's not something that I can list as a minimum or maximum. Does that difference make sense? Sort of, kind of? Okay. Questions for me on this graph? Okay. Let's take a look at number 2. Number 2, we have to graph on our calculators ourselves. Okay. So I have this typed in on my calculator. Why don't you guys take a second to type it in on yours as well? And we're going to look at all these same features. We're going to look at all these same features. If you don't have your calculator today for whatever reason, just follow along. So we're going to look at all these same features. Increasing versus decreasing, positive and negative, minimums and maximums. Now on our last graph, we had identified all of our x-intercepts and all of our minimums and maximums. I'm going to start by doing that on this graph as well. So I'm going to hit the menu key and I'm going to start with my x-intercepts. I can see them all right now. So I'm going to identify my x-intercepts. So I hit the menu key. I went down to analyze graph. And then remember, your calculator calls these zeros. So I find them one at a time by clicking my dashed line on either side of where I've got an x-intercept. Remember, on our calculators, we never have to guess where our x-intercepts or where any of our key features are. We can always find them exactly. So that's what I want you to do. And the only bummer is I have to find them one at a time. So menu, analyze graph, 0. For as many x-intercepts as I have. I've got one more. There's my last one. So I've got 4 x-intercepts. Remember, those x-intercepts are going to be where I switch my positive and negative intervals, or where I start and end my positive and negative intervals. So let's actually start with our positive and negative intervals, because I don't need to see, I know I've got a maximum up here somewhere, but I don't need to see it to talk about positive and negative intervals. So as I'm looking at my calculator and reading my graph from left to right, I'm starting way down here where my graph is negative, right? Below the x-axis for negative. So I'll have a negative interval from negative infinity until this point right here at -5. Now I'm above the x-axis. So I have a positive interval that starts at -5 and goes until -1. So I have a positive interval from -5 to -1. Now I'm below the x-axis again. So I'm in a negative interval from -1 until 4. So negative interval from -1 until 4. Then I've got a positive interval here from 4 until 7. So a positive interval from 4 to 7. And then I end with another negative interval. So after 7, we're negative. So we have a negative interval from 7 to infinity. Since everything else on my graph is going to be below the x-axis. Now to find our increasing and decreasing intervals, or to name them, I should say, we need to find our minimums and maximums. So since we're gonna go ahead and find those minimums and maximums, I'm gonna name them before we actually go ahead and name our intervals. That's a step to name the intervals, so I figure we might as well jot it down as we go. So I'm gonna go ahead and hit the menu key and do Analyze Graph. And we'll start with our minimum. We've got a minimum on the graph right here. Remember, I'm not trying to click this on the minimum. I want to click on either side of the minimum and let my calculator find that point for me. So I've got a minimum here. Is it local or global? Local. Yeah, I've got points on the graph lower than this, right? All these points here and all these points here. So I'm going to list this on the line for a local minimum. So I've got 0.298, comma, negative 4.68 as a local minimum. That's the only minimum on my graph. So now I'm going to find, I've got two maximums. I've got one here and one here. So I'm going to find this one first since I can see it on the screen. So menu, analyze graph, maximum. And again, I'm clicking on either side of where I know that maximum is. I don't need to try to land on it. Is this a local or a global maximum? This is local again. Yeah, I have points on the graph higher than this. So I have a local maximum at 6.34, comma 1.41. Local maximum there. And now let's find our last maximum. Menu, analyze graph, maximum. The nice thing about maximums and minimums is I don't need to adjust my zoom. My calculator can find them. So I'm going to click on either side of where I know that maximum lives. And my calculator sort of auto adjusts for me. Oop, I accidentally grabbed my point. There it is. Move our function over here. So there's our maximum, local or global. This one's global. This is the highest point on the entire graph. So it's a global maximum. So negative 3.8, comma 34.4. And then since our graph goes down forever, we don't have any global minimums. So I'm going to write none on the line for global minimums. And now the kind of tricky part here is it's a little difficult to see everything on my graph. So I'm going to name this first interval and then zoom out or zoom back in so that we have a little bit better picture of our graph. Okay. So as I'm tracing my graph from left to right, I'm going up. So I have an increasing interval, increasing from negative infinity until negative 3.8. I'm increasing from negative infinity to negative 3.8. Then I turn around and I'm decreasing. So I have a decreasing interval that starts at negative 3.8. And then I'm going to zoom back in. So I'm going to go to menu, window zoom, and I'm going to zoom in so I can see the rest of this graph a little bit better. Okay. So from negative 3.8 until, a lot of points in here, until here. Here's where I turn around, and that x value is 0.298. So decreasing interval from negative 3.8 until 0.298. And then I turn around and I'm increasing again. We've got an x-intercept with some cubic behavior there, but I'm still increasing until I hit this point here. So I have an increasing interval from 0.298 until 6.34, increasing from 0.298 until 6.34. And then I turn around and I'm decreasing again. So I end with a decreasing interval from negative or from 6.34 until infinity. We're decreasing since we're decreasing for the remainder of our graph. Questions for me so far? The last thing you looked at in your notes video was the idea that a quadratic function, a function that has a degree of 2, is just going to have one global minimum or one global maximum, right? You saw parabolas there. That's the name for that graph of an x squared function, of a quadratic function. And so the last thing we're going to do is find a couple of the vertices for our quadratic functions down at the bottom. So I'm going to go ahead and let's add a page here. So I'm going to add a graph, and I'm going to graph number 3 at the bottom of your notes page. So that's x squared plus 3x minus 4. And remember, my vertex is either the maximum or the minimum. Depending on the shape of my graph, it could be a maximum or a minimum. So our vertex would be this point here, our minimum, sort of the center of this U-shaped graph. To find it, I'm going to hit menu, then go down to analyze graph, and tell it to give me that minimum, just like we did on our last polynomial graph. Okay. So there's our minimum point. That's the vertex of our function. So negative 1.5, comma, negative 6.25. Let's take a look at one more. Let me delete this graph off of here. Hit the tab key to bring up a new function line, and we'll look at number 4. So that's negative 3 times x plus 1. We've got factored for this time, times x minus 5. Okay. I've got another parabola here. This time I'm going to have a maximum. I can tell that by the taper on the sides. They're sort of narrower at the top. I just can't see that vertex right now, but I can still find that maximum point. So menu, analyze graph, maximum this time. And I'm just clicking on either side of where I know that maximum will be. And I can see my maximum, or my vertex, is at the point 2, comma 27. Questions for me for today? Okay, again, this is all stuff you guys have seen. So this should have been familiar. You've done increasing, decreasing, positive and negative intervals before. You found minimums and maximums before. And you talked about the idea of a vertex before. So we're just sort of refreshing how to find all those things on our calculators. For the rest of class today, you have an assignment on Khan Academy that's going to be over the same stuff that we talked about here. So I don't think you're going to see the idea of a vertex, but that is what we're going to look at next in class. We're going to start talking more about exclusively quadratic functions. But you are going to see increasing, decreasing, positive, negative intervals, that type of stuff before we got to the quadratic portion. Okay, so Khan Academy assignment due by the end of the class period. And then for tomorrow, you have a notes video, or I should say for homework tonight, you have a notes video where we're going to start looking at those more quadratic specific ideas.